All right, my name is Jordan. I'm the founder at CodeTrack.dev. I'm going to go ahead and walk through this problem, Grasshopper check for factor. This is one of the first problems you'll find on CodeTrack. CodeTrack looks like this. You can go ahead and sign up for free. Click on what is CodeTrack. It will explain what it does and how to connect different accounts to it. It will build a profile on you as a developer. You can see lots of different developers here at all levels of their careers. And by clicking on your particular card or going to your profile, you can see your dashboard and then some problem sets of all kinds of problems to work through. We're working through this one right here, Grasshopper check for factor. It comes from Codewars, which is another free platform to use to practice coding. And let's go ahead and jump right into the problem. This function should test if the factor is a factor of the base. Return true if it is a factor or false if it is not. Factors are numbers that you can multiply together to get another number. 2 and 3 are factors of 6 because 2 times 3 equals 6. You can find a factor by dividing numbers. If the remainder is 0, then the number is a factor. You can use the mod operator in most languages to check for a remainder. For example, 2 is not a factor of 7 because 7 modulo 2 is equal to 1. In other words, 7 divided by 2 has a remainder of 1. Note, base is a non-negative number and factor is a positive number. All right, let's go ahead and click on train or train again if you've already done this problem. It will bring us over to our area to code. We see 3 areas here. Here we have the description of the problem, same as we just read. Here we have an area to write our code to solve the problem. And here we have an area to write tests for our problem. Let's expand these tests here. We want to say, okay, check if base is evenly divisible by factor. If yours doesn't say this, it's just because I have already updated my tests here a little bit. I always try and put something in that's very expressive and explaining what we're trying to do here. And here we say it has no remainder. In other words, it's true. For our first test, we want to go very, very simple. 1 going into 1 goes in 1 time with a remainder of 0. Therefore, 1 is a factor of 1. 1 times 1 is 1. We should get true. Let's go ahead and run our test there. We see expected undefined to equal true. So we don't have any code here yet. We're using test-driven development where we write our test and then we run our code. We expect to fail. Sometimes we are pleasantly surprised and we don't fail, but we expect to fail, and that will then lead us to write some code. We want to write the minimum amount of code that we need. In this case, we can simply write return true. And with that, boom, we have passed our test. Let's go ahead and make another test here. I'm just going to change one number. We'll move that to 2. 1 goes into 2 2 times. In other words, 1 times 2 is 2, or 2 divided by 1 has no remainder. So it should also be true, and we'll run that. And great, we see that that's true. All right, now let's make a new case here, and let's describe the opposite. It has a non-zero remainder, or it has a remainder. So if that were the case, we would say something like 1 and 2. 2 goes into 1, but it does not go in evenly. It will have a remainder. So here we want to say that is false. In other words, 2 is not a factor of 1. And let's go ahead and run that. Oh, and we see, yep, we've gone ahead and failed this test here. What code can we write to solve that? Well, one thing we could see in this case is if the factor is bigger than the base, it will never be true. So we could say something like, if factor is greater than base, return false. And let's go ahead and run that. Hey, we see that that's fine because 1 is not bigger than 1, so this still returns true. 1 is not bigger than 2, so this returns true. 2 is bigger than 1, so this now returns false. Let's add a new test here. So now I'm going to increase this to 2, and we want this to make sure we return false. So we will do, I guess we could do 3. And that should also be fine. Yep, looks good. Okay, let's move up a little bit more. Let's say, how about 4 and 3? Now 3 is not bigger than 4, but it is also not a factor of 4. So it looks like this test is going to fail. Indeed, it does fail. We have to think, okay, what code do we need to add here for this to work? In the instructions, they gave us a really big clue by saying, hey, you could use the modulo operator here. So if we said something like, if base divided by the factor is not equal to 0, return false. Let me just break that down a second. So our base in this example is 4. Our factor is 3. And what this means in simple English is, what is the remainder of 4 divided by 3? So when I was a kid, we did long division. I don't know if I can show this very well here, where you say there's 3 and then you make like the little box and you put 4 inside and you say, okay, 3 goes into 4 0 times, and so we bring it down and we end up with 3 here, and we say, oh, okay, our remainder then is 3, so we know here that this is going to equal 3, since that's our remainder, and that is not equal to 0, therefore we return false. So let's go ahead and test that. Hey, look, it's going good. We'll do one more of these. Okay, let's do something like 12 and 5. So 5 goes into 12 2 times, but it has a remainder of 2, so again, we want to say that is false. Awesome. With that, we're pretty much done. We could write some more tests for sure, but we've handled everything we need to here. We might do, what could we do? 99 and 10. So 10 will go in 9 times, but it's going to have a remainder of 9. And that's pretty much all there is to it. Since we've got a nice good set of tests here, we might say, well, do I really need this line? And we can easily comment it out, run our tests again, and see, oh, no, what? We don't need that line. And it's not adding any increased efficiency either. So let's get rid of it. Great. Our code is looking pretty good. I don't think we have anything more to do here. Let's go ahead and click on attempt. Wonderful. We've passed all of our tests and we're ready to head over to submit the problem. And there we go. So here is a similar approach. Base modulo factor equals 0 without the extra step of explicitly returning true or false. This evaluates to true or false, so we're always returning true or false here. And we see that most of them follow that same pattern. Great. Ours is a little bit more like this one here. And this one is even more repetitious in that it returns false here and also returns false here. You're never actually going to get to this case here. Anyway, great. We've solved it, and there we go. Hopefully that was helpful, and I encourage you to keep practicing on this problem and lots of others. Thanks so much.